Hello friends, welcome to my channel and explore the world of Microsoft Azure. My name is Rajneesh Kaushik and I'm a Microsoft certified trainer, consultant and an enterprise architect. For more latest videos and blogs, you can always log into my website rajneeshkaushik.com and subscribe to my blog. Please do not forget to subscribe my channel and click the bell icon so you don't miss the latest videos. Do like, share and comment. Organizations are really grapples when they try to implement their Delta Lake implementations or Lakehouse implementations. And why? Because there are different data formats available in the industry, and the top tier formats which are available in the industries are um, Apache Hudi, Apache Iceberg, or Delta Lake. So, which one to implement? And let me tell you, these three formats are better choices than putting your data into a proprietary format. So, these are better choices. But again, choosing one of them could be very daunting task. And how do we choose one format so that we can implement if we want to move your data from one format to another format? It is easy to implement. So for that, Databricks recently launched a format called Delta Lake UniForm or Universal Format. And this universal format helps you to merge these three formats, these three industry leading formats, and without extra data copies. So that means that you can create your data into one uniform format, but you can take advantage of these three industry leading formats. So let's dive deeper into this format. Delta Uniform transforming data interoperability. Let's get started. Here is the agenda. First, we will learn about the need for a unified data format. Then we will learn about multiple formats and single copy of the data. Then we will understand what is this Delta Uniform format and how it provides a seamless integration. Then we will delve deeper into setting up the Delta Uniform format and how, after setting the format, how to read the data from this Delta Uniform as a Iceberg client, and how Iceberg metadata is generated in this format. And then we will learn about checking the metadata generation status. After you generate the metadata, how do you understand or check the status of the metadata? And in case if you want to manually create Iceberg metadata or convert the Iceberg metadata conversion, how do you do that? And what are the practical implementations of this format? So let's get started. Okay, so first let's understand what is the need for a unified data format. And when you implement Open Data Lakehouse challenge, right? When you implement the Open Lakehouse, organization faces the challenge of selecting the optimal data format for their data, because the data is of different type and what will be the optimal for that. So aim here is to achieve the data democratization and interoperability, which means that you can interoperate the data from one format to another format, and you can democratize the data so that if any of these formats are used, you can easily convert your data from one format to another format. So there are these industry leading formats available: Linux Foundation, Delta Lake, Apache Iceberg and Apache Hudi. And let me tell you, these are very excellent choices for data storage, because these are better than choosing any of the proprietary format provided by the proprietary tools like Snowflake or any other tool. So what is the problem in this approach? The problem is that there is a decision making problem. That means you want to choose a single storage format, and that even is not easy, because you want to make sure that if I choose one format, can I reverse to another format, right? Or if I choose another format, can I again revert back to the earlier format? So these are the decision problems, right? And you don't want to lock yourself in one of the formats. So that is where the newly launched Databricks uniform format comes, and it actually provides a seamless approach for unification of the table formats. And in this format, you don't need to create an additional data copy for while converting the data from one format to another format. It is a single uniform format which you can use to uh, migrate your format from one to another one, because it is a universal format and it is understood by all the clients like Apache Iceberg or Hudi or any other clients. So multiple formats and single copy of a data. So first of all, let's understand what is the foundation of all these data format, the industry leading data formats, Apache Hudi and Iceberg, Apache Iceberg, and then Delta Lake. Actually, they are based on the Apache Parquet file system. And there are subtle but significant difference in the format, which is actually in the metadata of these formats. So metadata of all three serves the same purpose to understand the file, and there are some information which is overlapping across all these metadatas for the three file systems. So before the Delta UniForm came, switching between the open table format was copy or conversion based. That means you need to copy from one format to another format, or copy your data and convert it into another format. And that too, it only provides a point in time view of the data, because after you convert it, that point of time, whatever the data available, that data will be your point in time data. But with the help of Delta UniForm solution, it actually solves the interoperability puzzle. And how it provides it provides a live view of the data for all the readers, whether it is a Apache Hudi reader or Iceberg reader or Delta Lake reader, irrespective of any format which you are using. How this uniform format works then? The uniform format works actually by automatically generating the metadata for Iceberg, Hudi and Delta Lake, and uses a single copy of the data. On the top of it, it uses the metadata to understand these formats. So what are the advantages of this format? It is team can use the most suitable tool for each of these workloads. They can operate on a single data source without copying and conversion, and it is a perfect interoperability across the data lake and across the Delta Lake for all this ecosystem of Iceberg, Hudi or Delta Lake. Okay, so Delta UniForm is seamless integration. How this seamless integration is achieved? So first of all, it unifies the table formats without any additional data copies. And how it does is because on the top, on the base of it, it is a Parquet format. So if you see about Apache Hudi, and Apache Hudi creates a metadata on the top of Parquet file. Linux Foundation Delta Lake, it again creates a metadata of its own metadata on the top of the Parquet file. And Apache Iceberg again creates its own set of metadata. But Delta Lake with UniForm, it actually creates a metadata which is compatible to all these three ecosystems, and that too again against the Parquet file system. So that is how the Parquet file system and the metadata generated by Delta Lake UniForm is actually making it interoperable. So how does this help? Because with this you don't have to copy the data multiple places, multiple times, right? And the metadata differences are addressed in this metadata created by UniForm. So this is how it creates a seamless integration for the three ecosystems. Setting up Delta UniForm. So first of all, setting the Delta UniForm is very fast, easy, and it has a very minimal overhead. And once it is enabled, it operates seamlessly, automatically without any user's interventions. How do we create it then? Creating is very easy. When you say create table command, in that you have a table properties where you enable the format by the delta.universalFormat.enable formats equal to Iceberg, or it is Hudi or whatever format you want to enable. Now whenever you enable it, it automatically creates a metadata for additional format, and obviously when the table is created, that format is automatically created. Metadata update automatically happens when the table is modified, and it also eliminates the need for manual refresh command. That means you don't have to do any manual intervention. And more than that, it does not require any extra compute just for translating the table formats from one format to another format. And then you might be thinking that how do I write the data into this table format? So it's very easy. It's the standard insert into command. Insert into command main default uniform and the name of the table, and then value, and the way we do the normal SQL statement for insert. So this action actually triggers a Delta Lake commit command, because this actually goes into the Delta Lake commit, and it automatically generates the Iceberg metadata for the table based on these values. Okay, so now let's understand the benefits of Delta UniForm. Benefits of Delta Uniform is that first of all, it ensures the uninterrupted data pipelines. Whatever pipelines you have created, you can seamlessly use those same pipelines. It provides a seamless access to the latest data for all the different type of readers like Apache Hudi or any other readers. Performance and resource efficiency. So for this format conversion, there is a very negligible performance overhead. Okay, and it also helps you to optimal utilization of your computational resources. Even if you have a table of petabyte size, it is still suitable for that kind of petabyte size table. And if you compare the metadata size of against the data file size, it is a very small tiny fraction of the data file size. So that means that its overhead is very less. Resource efficiency is pretty good. Incremental metadata generation. Whenever you create a delta uniform, delta uniform can incrementally generate the metadata as and when the files are created and moved. Scopes metadata to change since the previous commits. So whenever the previous commit happens, after that if there are changes happens, then this will change. This changes will happen in the next commit. Delta Uniform's promise. Delta Uniform's promise is it is actually a transformative tool for data interoperability and efficiency across the three systems. So if you see Delta Live performance, the performance overhead is very less. That Delta Uniform off and Delta Uniform on, it is just less than 5%. Less than 5% is not too bad, and that too you are getting this kind of efficiency and interoperability and democratization across the different data data access patterns and data access ecosystems. Now let's understand the reading the Delta Uniform as an Iceberg client. So reading a Delta Uniform as Iceberg client is actually based on the Iceberg metadata specification provided by Apache Iceberg, and data returned to Delta Uniform can be read by any compatible compliant Iceberg client with ease. So what is the Iceberg specification? Iceberg provides a specification that whenever a reader tries to access the data, it actually determines the latest version of the Iceberg table, and there are two approaches it uses. Both are supported by the Delta Uniform. What are those approaches? First approach, Iceberg readers needs to know the path of the metadata table or metadata file. Once it has the metadata file, it actually reads that file and then understands the whole Iceberg based on the Iceberg specification. Now this approach can be very cumbersome because user need to update the metadata file path every time whenever a table change happens. So this could be really a cumbersome problem. Now another approach is REST catalog API approach. REST catalog API approach is that there is a API exposed, and this is the most recommended approach by community of Iceberg community. In this approach, client actually communicates with the catalog, right, with the REST API call and get the latest state of the table. It eliminates the manual refresh needs because manually you don't have to intervene and you don't have to worry about the path of the metadata. Now let's understand the Unity catalog's implementation of Iceberg client. So Unity catalog implements the open Iceberg catalog with the help of REST API, and this is implemented in the Unity catalog's HMS API support. This approach offers a open access to uniform table without Databricks compute charges, and it helps you to interoperate, auto refresh support, federation to other catalogs as well. So Unity catalog, Apache Iceberg, there are client libraries which is implemented, and these client libraries can be used by the REST API call to Unity catalog. These client libraries support, they can access the Unity catalog Iceberg REST API catalog specification, and it simplifies the task of managing the table metadata. So now let's understand this diagram. So there are two options available. First option is user provided metadata path, and here manual access to the most recent data is available because you need to specify the user path, but again in this there is no server side compute charges. And this is another approach. In the other approach, you are providing the Unity catalog REST API call, and again there is no support for, there is no need of compute charges. for the open data standard. Automatically it is accessing the most recent data because it is REST API call, and this supports the time travel. So this is how the Delta Unity catalog implements this Iceberg format seamlessly. So you might be thinking that how the Iceberg metadata is actually generated. Iceberg metadata is generated whenever a Delta Lake transaction is finished or committed, and same compute resource is used for Delta Lake transaction. This same compute resource is clubbed for the metadata generation. But user still have a option to manually initiate the Iceberg metadata generation if user wants. For Delta tables, whenever a regular commit happens, multiple Delta commits can also be grouped together for the one Iceberg commit. So that means if there are multiple commits are happening, so they can be grouped in together, and that commits can make only single Iceberg commit, so that we can improve the write latencies. Delta Lake ensures that at one point of time there is one metadata generation is active at a time, and if there are multiple metadata is generated, then it will create a problem, right? So it ensures that there is only one metadata which is generated. If a commit starts a second concurrent metadata generation, it will only commit to Delta without triggering the Iceberg metadata generation. So that ensures that at a time only one metadata generation is active. So with this approach, you avoid the potential delays in metadata generation where the workload has frequent commits happening. So how do we check the metadata generation status? Whenever this metadata generation is done, there are two specific metadata fields are generated. First is converted delta version and converted delta timestamp. Converted delta version provides the version of the metadata, and converted delta timestamp is a timestamp of the latest delta commit for which Iceberg metadata was successfully generated. So with the help of these two fields, you can check the metadata generation status at any point of time. But how do we see this metadata generation status? With the help of show table properties command, you can find out the metadata fields which is added recently into the table, metadata table. You can trigger manually the Iceberg metadata conversion. Iceberg metadata conversion can be triggered manually, but it is not really required typically, but it could be very useful for certain set of scenarios. And why it is required? Because if suppose some cluster ends before the automatic metadata generation is successful, then in that use case it is required. If there is interruptions in the metadata generation due to the errors or job failures, then you can trigger it. When a client which is writing the UniForm does not support the Delta UniForm, and in that case the metadata writes to the Delta table could be very useful. And good part about this is it actually, whenever you manually trigger it, it actually happens real time, which ensures that Iceberg reflect the Delta table's latest version upon the completion. Now you might be thinking, how do I trigger it manually? So for triggering it manually, the command is msck repair table name sync metadata. With this command, you can trigger it manually. Okay, so you might be thinking about enough of the theory now. Where do I implement all these capabilities? So let's delve into some practical examples. So one of the example is reading the Delta Lake as a Iceberg in BigQuery by supporting the metadata location. So this way, if you create external table and then you specify the URI and then you specify the format, and in order for finding it out the Iceberg metadata path, you can go into the Data Explorer and find the path which is kept here, and you can also retrieve the metadata location with the help of a RESTful API in the Unity catalog, and then table name, and then with the get call you can retrieve the path. So this is one of the example practical application. Another application is the Trinos support for Apache Iceberg REST catalog API. So this way Trinos actually support Apache Iceberg RESTful API. And how does it support? It is very easy with this API to reading Delta Lake in a BigQuery. So Trino actually makes a REST API call, and it helps you to read the Delta Lake with the BigQuery. How does it do this? it actually creates a iceberg properties in the etc/catalog/iceberg properties file, and in that file you provide some values like unity catalog iceberg URL. Iceberg URL is in this format, which is given here, and in this Databricks workspace URL is again your Databricks workspace URL. So you can incorporate that, and based on that you can provide the unity catalog iceberg URL. And once you provide this information in the iceberg properties, then you can make a RESTful API call with the help of Trino and then make the things happen. Thanks for watching, and do not forget to subscribe.